Hello, everybody. Warm welcome today in our Frogeex Green Tech Live. Today it's a great pleasure to welcome Fred Hornaday, a dear friend of mine. We already worked for several years together and also a bamboo expert for several years working within the industry with many different aspects and perspectives of how to manage, grow, plant, utilize bamboo. So today the tagline for us is Bamboo Biochar. With this, let me welcome Fred first and give you also a little bit of an intro on his background, so you know who you are listening or watching today. So, hello, Fred. Nice that you are here, and thanks for taking the time.
Hang on, my pleasure. Always, it's always wonderful to speak with you and touch base and talk about hot topics related to sustainability and environment, and of course, bamboo and biochar are two of my favorite topics. So it's a real pleasure to be here. Thanks.
Absolutely, absolutely. A pleasure on our side. So for all those that are watching the stream today on LinkedIn, Facebook, or YouTube, you have the comment section if you would like to, share your thoughts, observations, or whatever questions you would have to Fred. I mean, really recommend to kind of reach out to him. You have now a great opportunity to have your questions answered and, gain some knowledge on that. So let me just give you a little intro on our guest today. Fred Hornaday is a bamboo consultant and the founder of Bamboo Batu, a bamboo platform that provides rich informative content and advisory services for bamboo projects and commercialization. Fred has also recently joined the Bamboo team, where he is responsible for the biochar supply chain on the global scale. He's actively involved in promoting biochar production as a key component in managing waste from the bamboo processing and carbon dioxide removal efforts throughout Africa, Asia, and Latin America. His work addresses climate change, improves soil fertility, and manages organic waste, while actively contributing to the generation of carbon removal credits. With this, let me, again, welcome Fred here with us. And Fred, maybe you would like to kind of share with us some kind of first words on why is bamboo biochar so important for you, and then we can jump into a little brief for the audience.
Great. Thanks, Jana. So I've been promoting bamboo for a long time, as you know, as you mentioned. Bamboo is just such a super fast growing plant, super sustainable. And because of that, it removes carbon faster than any plant because of its high growth rate. And the way it grows as a grass, you can harvest it without killing the plant. So as you harvest bamboo, it continues to grow without having to reseed and replant. And so it's just a super plant for sustainability and renewability. And as we know, plants and trees are essential for climate change mitigation, for removing CO2 from the atmosphere. And so that's a super important thing, and bamboo is really good at it. More recently, in the last couple of years, I got into biochar, which has its own great benefits for removing carbon and lots of co-benefits for improving soil and addressing other issues in the tropics. So with Bamboo, we develop a variety of biochar projects based primarily in the global south, so Africa, South Asia, Latin America. Not strictly with bamboo, but we do like to use bamboo. Bamboo is a great biomass because of its renewability. And also for biochar, it just cooks really well. It's woody, so it's high in carbon. Mm-hmm. It burns well without producing a lot of ash, and so you get a high quality biochar, good cook times, high carbon content, good soil benefits. So it's a prime candidate for biochar production, but it's not the only type of biomass that we use at Bamboo.
Great. So maybe we can also talk a little bit on the side when we have the Q&A session, because it's also quite interesting to understand what are your current projects, what are maybe the hot topics you work on, and just to understand where the journey is kind of also going for biochar production and the market development there.
Perfect. Should I go ahead and share my slides?
We can definitely do so. We're more than ready to hear about biochar.
Nice. Yeah, biochar for carbon capture, soil regeneration, and carbon credits. So yeah, let's get into it. So yeah, we're talking about climate change. We're talking about CO2. When we talk about climate change, we usually describe it as a carbon problem. There's too much CO2 in the atmosphere. And so there's kind of this war against carbon. But it's actually not, carbon isn't necessarily a bad thing. It's just having carbon in the atmosphere is a problem. But carbon is essential to life. I think humans are about 16% carbon. So carbon's super important. Carbon is super important in the soil. And right now, not only is there too much carbon in the atmosphere, but there's also a real shortage of carbon in the soil. So these degraded lands, the desertification of land and farmland has a lot to do with there not being enough carbon in the soil. And so biochar is an important solution for that. We have a proven technology for removing carbon dioxide from the air. It's called trees, plants. Plants have been removing carbon dioxide from the atmosphere for millions of years, and they do it really well. And as we know, with photosynthesis, the plant absorbs CO2, it's carbon dioxide, and then it produces oxygen. And we talk about this a lot. It's something most anybody who's been through primary school probably learned about photosynthesis. But there's a real emphasis on converting CO2 into oxygen. But we often forget that the other part of CO2 is the carbon, and that carbon is important. The carbon actually goes into the plant, into the soil, into the roots. And so while the oxygen is released back into the atmosphere, which is very important for us to breathe, the carbon gets sequestered into the roots, ends up in the soil, and is, yeah, super important building block for life. And so how does biochar fit into that? When you think about biochar, it's cooked. To produce it, you have to burn it the same way that we produce. It's basically the same process as producing charcoal. And so it's a little bit counterintuitive that this is going to address climate change because you have to cook it in a really hot oven. But let's take a look at the life cycle of biochar. So this little infographic I made is based on bamboo biochar. But like I said a minute ago, there's lots of different types of biomass that can be used to make biochar. So yeah, let's take a look. So at the top of the screen here, vigorous vegetative growth is where we're going to start. So you start out with a plant like bamboo. It grows super fast. As it's growing, it's absorbing CO2 from the atmosphere, releasing oxygen, and storing carbon. And so you have that CO2 coming out of the atmosphere and being absorbed and processed by the plant. And in the case of bamboo, mature bamboo is harvested and turned into biochar through pyrolysis. So you can harvest, like I said, you harvest the bamboo. If you harvest maybe 20% of the poles on a clump of bamboo, leave the other 80% in the ground, and you still have a very healthy organism. The bamboo will continue to be very productive and very healthy, and you can continue to harvest about 20%, more or less, of that bamboo each year. So it's a great source of biomass, and that with bamboo, you can cut it in little pieces, throw it in the kiln, and make yourself some biochar. It is done in a pyrolysis method where it's a oxygen deprived environment. So instead of producing lots of smoke and then ending up with a lot of ash at the end, like you normally would if you made like a campfire or a fire in your fireplace, it's cooked in such a way that the oxygen doesn't get in there, and you end up with very little ash and very little smoke. And at the end, you have what looks like charcoal, basically. And biochar is cooked at a slightly higher temperature than charcoal, but it's essentially the same. And so that's the process that we call pyrolysis. And when you do that, the carbon the carbon that was in the biomass of the plant is stabilized. So the plant, as it's growing, has removed the CO2 from the atmosphere, and then when you cook it as into biochar through pyrolysis, the carbon is fixed in a stable state, and you'll have solid carbon. And once you put it into the ground, that carbon will stay in the ground for hundreds of years, up to 1,000 years, and so you have a very permanent carbon sink where this carbon is stored. It's kept out of the atmosphere and it's buried in the ground. And not only is it out of the atmosphere where it contributes to global warming, but in the ground, it's going to increase the fertility of the soil. The benefits of biochar, it's pretty amazing. It's like a sponge. It's got all these little nooks and crannies. It's got this super complex surface area where it can absorb nutrients. It can help with moisture retention. If you're using fertilizer, it will retain the fertilizer much better with a lot less runoff. So whether it's rainfall or fertilizing or something else, the biochar helps to retain those nutrients and that moisture in the soil, producing a healthier environment for the plant to grow in. Some people refer to biochar as like a hotel for microorganisms because of all those little nooks and crannies. The microorganisms can find all these little pockets and little bubbles, where they can fill those gaps and create a super healthy topsoil area. And that is a serious problem in this day and age with farming. It's been said that we have something like 60 harvests left with the current state of topsoil on the planet. In other words, if we keep farming in the way that we have been farming for the last 100 years or so, the topsoil is just going to erode and weather away into just sand and dust, and we're not going to be able to produce healthy, nutritious food. So the last several decades or 100 years maybe, farming has really been focused on just producing using these fertilizers that are just optimized to deliver the perfect balance of nitrogen, potassium, and NPK, phosphorus, potassium, and nitrogen. And that gets the plant to grow like it's putting the plant on steroids. But it has been ignoring the health of the topsoil. And so biochar is addressing that need to make for a healthier topsoil. And with a healthier topsoil, you don't need as much of that NPK fertilizer, which is in itself a petroleum product, which has a carbon footprint. So by reducing the use of those kinds of fertilizers, you're reducing the carbon footprint of your farm, while at the same time you're absorbing all the CO2 from your vegetation and from the production of biochar. So it's many, many benefits of biochar. I hope I spelled that out clearly. It's a lot it's kind of like a spider web when you start to explain biochar because there's so many different things related. And not only is it the environmental benefits of removing carbon, but at Bamboo, we always like to talk about the co-benefits. So beyond carbon removal, when we're talking about decentralized biochar, which is small biochar producers in the tropics in the global south, as opposed to these massive industrial biochar units that you might see in Northern Europe or North America. We have those are the types of projects we work on at Bamboo, or these smaller ones. So each village might have a little biochar production. And so that creates more job opportunities in all these different locations. And so some of the co-benefits there are waste management. Most agricultural activity has some form of waste at the end. There's it could be a bamboo waste from furniture production. It could be coconut shells left over from coconut milk. Rubber plantations have a significant amount of waste as the old rubber trees are pulled out, new ones are planted. So just about every kind of agriculture, there's going to be a waste stream. And normally that waste would just lay on the farm and decay. Sometimes they throw it all into a pile and burn it. This is a huge problem throughout Southern Asia. The burning of rice fields and rice straw, for example, just creates, tremendous pollution. So instead of burning off the waste that way, the waste can be converted into biochar, which is done in a much cleaner manner, producing far less smoke and ending up with a valuable product. Instead of turning all that waste into ash, you're turning it into something valuable, biochar, which goes into the soil. And like I said, it's very important for soil regeneration, bringing those microbes back into the soil, retaining moisture, nutrients in the soil, which ultimately decreases the need for these inputs, these expensive chemical fertilizers, and at the same time increases crop yields, so addressing food security issues in these parts of the world. And then the social benefits of creating jobs through these projects, we're very committed to ensuring that employees are being paid fairly, gender equality issues are addressed, and so there's lots of other benefits to these biochar projects besides simply sucking CO2 out of the atmosphere. So we're pretty happy about the kind of work we do and all the benefits that there are. The most recent project we worked on was in Thailand. I've got some real nice pictures. Thailand is a super photogenic place, so it's easy to get good pictures there. These are some women working in a bamboo processing area. They're just right in the middle of this bamboo forest, and they're cutting down bamboo poles, and they cut the poles into certain sizes, like standard sizes, and then organize them for either to send them off to a furniture factory or for agricultural use as stakes in the ground to hold up crops. It could be all different manner of applications. And as they do that, this woman is really happy with her work making bamboo. Everybody in Thailand is just smiling all the time. It's just such a fun place to go. And if you like bamboo like I do, it's just amazing. There's just bamboo everywhere. And bamboo has a way of making people smile a lot, it seems like. And as they cut the bamboo into those standard sizes, they end up with all these little offcuts, all these bits and pieces at the end of the pole. And one of those facilities where those women were cutting poles produces about close to a ton or so of bamboo each day. And there's facilities like that throughout the region. So there's tons and tons of this bamboo waste on a daily basis. And before our project came along, they were just burning this bamboo waste in an open fire because they didn't have space just to store all this bamboo waste. They needed to get rid of it, and the fastest, easiest thing to do would be to burn it. And doing that on a daily basis at all of these different locations, you can imagine the air quality in the region would suffer tremendously from all that smoke in the air. So the biochar project not only saved that waste problem, but also turns that waste into something much more valuable as a soil additive, like we talked about. Here's an example of or a photo of a couple of the guys shoveling biochar out of the kiln. That's a Kontiki kiln. That's the type of kiln that most of our projects use. It holds about 1.5 cubic meters of biomass or biochar, and it takes about 2 to 3 hours. About 3 hours to cook the bamboo, and then another maybe an hour for it to cool off before they can scoop it out. So they cook. They've been cooking 2 batches per day in one of those kilns. They could do up to 3 batches, I think, but 2 seems like a good work schedule for them. So they've got 2 kilns like that. So they're producing quite a bit of biochar. And then they're applying the biochar on a variety of crops. Here they are putting it around their bamboo. The people that I spoke to there, they said they can already see a difference from using biochar for a few months. They can already see an improvement in the bamboo, producing more fresh shoots, more shoots than usual in the growing season. So it seems to be yeah, it seems that they're catching on pretty fast to the benefits of biochar. It's a tricky thing in these parts of the world. Not a lot of people know about biochar. It's on the one hand, it's an ancient technique, but on the other hand, it's something new and revolutionary because farmers have been trained to use these synthetic fertilizers for the last several generations, and so now reintroducing biochar as an alternative takes some time for people to open up to that idea. But once they start using it, the results seem to be evident pretty quickly. So we're happy to see that. They're also applying biochar on other vegetable crops and rice paddies. There's millions of hectares of rice in Thailand, so it's a great place to apply biochar. So our projects are, benefits of biochar. So the benefits, like I talked about, we're utilizing this waste biomass, stopping the decay and incineration of waste, regenerating the soil, improving moisture retention and nutrient retention. We're removing CO2 from the atmosphere, addressing one of the most leading causes of climate change, and then generating carbon credits. So turning residue into revenue, I like to say. And that's a key part of what Bamboo does as a company. We help these projects to generate carbon credits. And in order to do that, they have to follow some fairly strict guidelines about how that biomass is sourced. We have to prove that it's a waste biomass and they're not just going into a forest and cutting down trees and cutting down bamboo willy-nilly. It has to be a demonstrated waste stream or a renewable crop like bamboo that we can say we're harvesting it sustainably and growing it specifically for biochar production. And then it has to be cooked through pyrolysis in a specific way with minimal emissions, minimal smoke from the kilns. There's a few different ways to do that. We mainly use those Kontiki kilns. And then the biochar has to be mixed with something like fertilizer or manure. And then finally, the biochar needs to be applied to the soil, like we saw in that last picture. Until the biochar goes into the soil, you can't really, you can't call it a carbon sink. It's just a pile of carbon. Biochar being about 70 to 80% carbon. But it's not really a carbon sink, like I said, until you put it into the soil. So you put it into the ground around some designated crops, and then we have photographs and GPS tracking of where the biochar is applied into the soil. And at that point, we can turn that biochar into carbon credits. And so it's a very important revenue stream for these projects. And to make the projects feasible, the carbon credits are very important because at the moment, there's not much of a market for biochar. We are aware that it's super beneficial for the soil in all these ways, but in many of these parts of the world, they're not so aware of these benefits, especially in rural communities and the farmers, and in Thailand or farmers in Africa, they're not so familiar with biochar, and so it's hard to sell biochar. And so to finance these projects, they need some form of subsidization, and that's kind of what the carbon credits do. So the carbon credits are sold to companies in the global north, in Europe and North America primarily, companies that need offsets for their activities. Right now, it's a lot of tech companies, Silicon Valley, for example, big supporter of carbon credits. And by purchasing those carbon credits, they are supporting these projects in the global south. At least the Bamboo projects are based in the global south. And so we see all the different co-benefits, like I said, and social benefits of attracting this carbon credit revenue to these parts of Africa and Asia and Latin America. And so with the carbon credits, so the way that works out, about 5 tons of biomass will convert to about 1 ton of biochar. And these numbers vary depending on the type of biomass that you're using and other circumstances, other conditions. But it's roughly a 20% conversion. Could be a little bit less than that. But let's just say about 5 tons of dry biomass to get 1 ton of biochar. 1 ton of biochar is the way we produce it in the Kontiki kiln. It's equivalent to about 2 tons of CO2. So there's actually more CO2 than there is. The way it works. The way it works is there's about 3.5 tons of CO2 in 1 ton of carbon, because we're talking about solid carbon versus CO2 as a gas. And then when we factor in the other emissions from the kiln or from the transportation and other activities around the project, it works out usually to approximately 2 tons of CO2 per ton of biochar. So that's 2 carbon credits, because carbon credits are measured by tons of CO2. So 2 tons of carbon credits for 1 ton of biochar. So that our projects so far, we've been paying about $100 to $120 per carbon credit. That price can definitely fluctuate, so don't hold me to that, but that's been right around the number we've been at so far. So usually our projects can make about $240 per ton for their biochar, plus the other co-benefits. And then if they can sell the biochar, there's additional revenue from that as well. So that's kind of how the finances work out. And that's about it on bamboo and biochar. I hope I covered everything, and there's a lot to explain with bamboo and biochar. Like I said, it's kind of a spider web. You start talking about carbon here and there, and it's so connected to so many different things, which makes it a little bit difficult to explain, but really exciting to be a part of. So if you have any questions, please fire away.
Fire away. I mean, thank you so much, Fred, for this amazing presentation. I mean, also really much appreciate that you're also so transparent on the data. You know, the calculations for the carbon credits, it was already a question that was kind of, sneaking in. So you answered it already before it came. So amazing. And because we have like a little bit of time, let's go straight into the questions. So you mentioned the market for biochar is a little bit limited right now. Still, is there any development, like regional development, that you see? I mean, you have FLECT projects in Asia, Americas, Africa. So where do you see the biggest move on this? And yeah.
So in Thailand, where we've been working on this project, there seems to be a bit more awareness there. There seems to be more of a like organic farming community and mindset, but it's still it's still difficult. It's something that we're working on together with those project developers in Thailand. And there's a lot of data out there, but it's pretty scattered when it comes to explaining the benefits of biochar. The benefits really depend so much on the soil type and the crop type and the climate type. So if there's a study done in Ghana about how biochar works on cocoa beans, cocoa trees, that science isn't necessarily going to be very persuasive or convincing for a farmer in Thailand who's growing rice or cassava or something. So it's hard to get real specific relevant data to persuade the farmers, and so that's an area that we're definitely working on, trying to promote more of that research and to make more of the data from those types of research more available, and kind of building a database around that. And that's part of our projects. One more thing we encourage them to do is when they're producing biochar and applying it into the soil, to make sure that they want to put biochar everywhere, because the project developers know that it's beneficial, and so they want to put it everywhere. But we always have to remind them, like, leave a certain area where there's no biochar, so that 6 months from now you can go back and show people, look, this is where we didn't add biochar, this is where we did add biochar, and you can see the difference. And usually you can see the results pretty quickly and pretty convincingly. But we've had a bit of a problem that people want to just put it everywhere because they don't, well, we don't want to skip this part of the farm because we want all the farm to grow well. So they want to put the biochar everywhere. So that's
understandable. It's understandable, but I also got your logic. We have here a question from Sangmitra. So let's take this one first. How much? And thank you so much for the questions. Also, Michael, thanks. Michael Twist, thanks for the comments. How much biomass approximately reduce while transforming in biochar? I mean, we had this answered, I believe, in the presentation, but let's recap it quickly.
Yeah, and I went through a lot of numbers there, so that's fine. Usually, it depends on the pyrolysis technology that you're using. In other words, the type of kiln, how you're processing your biomass. But it's usually something like around 20% is kind of the rule of thumb for the low tech kilns that we're using. It could be between 15 and 20% if you invest in some real high tech machinery like a retort kiln or something. You can get more like 30%, but then your capital expenditure is going to be much higher to get the project started. So it's kind of a trade-off how much money you want to spend on equipment. In the long run, it should pay off, but most of our projects, developing projects in Africa and Southeast Asia, they don't have huge amounts of money to invest to get the project off the ground. So these smaller projects with Kontiki kilns, we're looking at startup cost of something $10,000 to $15,000 maybe. Depends how many kilns they want to start with and things like that. But fairly low cost to get a project like this off the ground. The kilns that we use, these Kontiki kilns, like in the picture, it's a 1.5 cubic meters or 1,500 liters. And those kilns, you can have them produced locally. We share the diagrams for how to build that. And usually it costs between $1,000 to $2,000 US, depending on local cost of materials, local labor costs. So, but yeah, you can find high tech kilns that are $20,000 to $30,000, or $500,000 for these really nice pyrolysis machines. So we use these low tech kilns just to make the project more accessible to more low income parts of the world.
Absolutely. Very interesting approach, and definitely, support that. What I also find super insightful, you have the full background, no? Starting with bamboo, at the retail part, and farming, growing, developing projects, helping investors, to kind of assess their projects or endeavor or idea. And now basically looking at the waste part, at the kind of side effects of bamboo processing. Do you see this kind of circular concept? Because this really comes close to what circularity should look like. You have a very renewable resource that is super regenerated by per se, like the properties of the plant already. You have like a ramp up period, this, I don't know, 3, 4, 5, maybe 6 years, where you can earn money basically with the carbon credits until you have maybe some capacity. Combined with agroforestry, we also had a little bit a chat on that. How agroforestry can be beneficial to kind of combine the income sources for people that start with bamboo. And then you go into kind of utility of bamboo and the waste management. Do you see this already happening, or is it something that is kind of, what is your perspective? And how do you also maybe approach it with bamboo or, with your other projects?
Yeah, really good question. There's so much talk about circular economies and circularity right now, which is fantastic. And bamboo is definitely an excellent candidate for any kind of circular economy model, especially in the tropics for sure, where bamboo grows so well. So this project in Thailand, they're dealing with really old bamboo groves. I think these are just native bamboo forests, basically. And so they've been managing these forests for generations and generations. And so it was fairly easy to kind of close the loop and make this circular.
Mhm.
Um, but it was an important step that hadn't been done before to to use that waste stream, which was the bamboo was 80% of it was being used to make these different size poles for different uses. But let's say, I don't know, maybe 20%. I don't know exactly, but there's, like I showed in those pictures, there's piles and piles of this bamboo waste every day. And so we really closed the loop by turning that into biochar and then putting that biochar back on those bamboo groves to make the bamboo groves even more productive. And yeah, so to answer your question about these agroforestry projects, yeah, there's so much interest in those because of the carbon credit market right now and
Mhm.
the need for forests, the need to remove CO2 from the atmosphere. I think anybody in the right mind realizes, like, yeah, we need to do whatever we can to remove the CO2, and forests are like the ancient proven technology to remove.
Very cheap, very effective. We love them.
Yeah,
I mean,
and
mhm.
and so they recognize that biochar is a super important component in these projects, partly because of the financial factor. If you're planting a forest, it's going to, with the bamboo or other trees, it takes years and years for trees to get established. Um, but you can start making biochar pretty early on, and with a carbon credit market for biochar, that's a great way to start getting some revenue in earlier
Mhm.
in the first couple of years, and
Mhm.
then it's going to be a few more years before you start getting products from your bamboo farm or from your fruit trees and things like that. Um, which is why I'm a big proponent of planting things like banana, like we talked about earlier, planting
Mhm.
banana with bamboo. Like I said, you get bananas within about 9 months, and you can get harvesting bananas for a few years while you wait for the um, for the bamboo to ripen and mature. But there's a lot of different ways to mix bamboo and different tropical trees and annual crops and things. That's kind of a whole. We could really go down a rabbit hole in that if you want to, but
Let's keep it for the next one. Let's keep it for the
yes,
next one because
yeah,
there
for
are so
sure.
many
That's a great
aspects.
topic.
Yeah, yeah, yeah. There are so many aspects, and it's great to have this reports and these studies from the projects that are running to understand really what is the utility, what are the combinations that work, and what are the results that are being achieved. So this is amazing, and much appreciate also the data and the information that you share on your projects, like now from Thailand and maybe from others to come. And also, when we talk about the application of biochar, so one question would be, I mean, we also have a massive demand for soil regeneration in Europe. There is like
Mhm.
this overwhelming numbers of land degradation and the
Mhm.
percentages which you see everywhere you look. So would you see also a market potential over there to kind of export it into Europe, or is it something that you see has some potential for the years to come? Or
Yeah, it's a good question. Also, for these projects to get carbon credits, it's pretty important to keep not only for the carbon credits, but also for the
Mhm.
communities. It's important to keep the biochar there locally, and it just makes sense in terms of circular economy to use the biomass within this region and make biochar and put that biochar back into the soil in that region.
Mhm.
Otherwise, sorry, otherwise you're exporting biomass, exporting
Mhm.
biochar, and the soil in this region is going to continue to get depleted. So it's pretty important, um, I believe, to keep the biochar in that community, in that region. As far as the carbon credits, it's also very important that the biochar doesn't have this big carbon footprint, and you're not putting it
Mhm.
on a boat and shipping it to another continent.
Transport, absolutely. Hmm.
Transportation, yeah, is going to be taken into account in the carbon credits. And so, yeah, we definitely try to keep the biochar within the same country, at the very least, but ideally within about a 50-kilometer radius of the project.
Hmm.
Sometimes it might go a little bit further, but over international borders. So we would never, for these projects, we would never be shipping biochar from Thailand to Europe, for example.
Great, great. So when talking about, because you mentioned, I mean, so when you mentioned also some alternative sources for biochar. I mean, do you also have within Bamboo some European-based projects, or in, I mean, you mentioned Americas, that would work with other plants or, you know, residue, or that you can share with us? Just, you know, 60 seconds.
Yeah, we don't
Only.
work. We don't really work in North America and Europe. We're pretty focused on the global South, where we see all the opportunity for these co-benefits and the social impact that we can make with the projects.
Mhm.
There are some larger projects in Europe and North America. They generally are using these more high-tech kilns that I referred to. They're like $100,000 or several $100,000 for these kilns, and they're producing pretty large quantities, industrial quantities of biochar. I'm not so familiar with those projects. Usually they rely on like forestry waste from lumber mills, like leftover sawdust and odds and ends and bits of wood that don't like wood that's got knots in it, or you know, different waste stream basically. And there's industrial quantities of biochar coming from those projects, which is great, but it's a whole different category from the projects that we do, where we see these social benefits and social impact that we can make in the tropics and in the developing countries.
Mhm. So I would have three last questions before we kind of close, or we let you go for today. Because
Sure.
no, it's such an amazing session. So if you like to share with us some insights on that, would be amazing. What are the social impact that you see, or what is the social impact that you see or observe in the communities within the projects that you work with? What kind of development you can observe over there?
Well, first of all, it's the management of waste. So instead of having piles, and I'll just use the Thailand example, piles of bamboo that they would be burning at the end of the day, and just all that smoke in the air, polluting their environment. And instead of spoiling the environment, that way they're able to actually sell that waste, so that now it has actual monetary value. We don't pay very much for it because we know it's something that they normally would have thrown away or burnt, but they are able to get a little bit of revenue for it. So we're providing them with a service to do that, and a little bit of income and cleaning their air. And then the biochar is now available throughout the community, and that can be added to their farms to improve crop yields. The projects are creating jobs for the people operating the kilns, people who are gathering that biomass, people who are driving around, applying the biochar on different farms. So there's quite a few different jobs related to the projects. And in places like where we were in Thailand, they pointed out several times that without this project, most of the young people working on these jobs would have to move to Bangkok or move to a big city to find work, because there's not a lot of economic opportunity in these rural areas. So they're able to stay there closer to their families instead of moving off to the big city. And so, all the people we spoke to were really grateful for the project to be there. So which is really encouraging for us to hear that. We got a lot of really good feedback from the people. And another thing we noticed on that project, which you could see in some of those pictures, was the gender equality, which is a serious issue in a lot of these parts of the world. There were lots of women involved in the project, and at every level of the project too. It wasn't just the day laborers, but also some of the managerial personnel were females. One of the three co-founders at the executive level, she's a woman. And so that was also real encouraging to see. It's not just a male-dominated, agricultural
Space.
operation.
Yeah, super, super excellent. So it's going to be like fast now. When talking about application, we have to be fast. We had no great time. So application, can you tell us like several applications? Where can we use biochar? What is it?
One of the questions we always get that I thought of somewhere during the presentation, but I didn't address, was how much biochar to add. Like when it comes to application, how much biochar do you add? And we're usually we recommend about 5 to 10 tons per hectare. Again, it depends on what kind of soil you have to begin with, what kind of crops you're using, planting, climate, other local conditions. But you can apply it. It's really good on acidic soil because it will lower the pH, or lower the it raises the pH, lowers the acidity of the soil. So that's good. Tropical soil is often really acidic, so it's good for that. But it's really good on most any crop, unless you have like just super rich volcanic soil to begin with that doesn't really need anything. Then yeah, biochar might not make a great impact there. But yeah, it could be, you could add it to trees in a forestry project. You can add it to rice crops and annual vegetable crops. And we have a project in Namibia where it's, savanna, almost desert terrain, and they're applying it there to help restore the savanna. A lot of the native savanna has been kind of dying off, and these invasive weeds have been growing in and replacing the native grasses. And so we're removing those invasive shrubs and trying to restore the grasslands. And the biochar is an important component in that restoration process. So.
Great. So last question would be, what are the indications for quality of biochar? I mean, is there something you can give us on the way to kind of, this is how you identify high quality biochar?
As part of the certification for the carbon credit standard, we do ship a sample of biochar to a certified lab in Germany. There's a handful of labs that are certified by the European Biochar Certificate, the EBC. And they'll test it for things like carbon content, density, some other different types of mineral contents. And those are, the carbon content, I think, is the most important. There's a couple other things. I'm not the best one to ask about the scientific, some of the scientific stuff. But the carbon content is, I think, the most important metric. And yeah, different types of pyrolysis and different technique of how you operate the kilns can definitely influence the quality of the biochar. So you want to make sure it reaches a high enough temperature, for example. Like I said, that's kind of the key difference between biochar and charcoal, is in the biochar production, the kilns reach a higher temperature. So I think we want to get at least like 750 or 800 degrees Celsius. As opposed to charcoal, which only gets up to maybe 550 or so Celsius. I want to double check those numbers. Like I said, I'm not the chemistry PhD on the team, so that's a kind of a high level breakdown of that.
Absolutely appreciate it. And so here we have a question also again from Michael. Thanks a lot. So that's the last one. Then we need to cut off. So everybody that comes after, we manage that through the comment section after the call. In volcanic soils, does it increase water holding capacity?
Ooh, that's a good question. Yeah, I was afraid when I mentioned volcanic soil, somebody might raise a technical question like that. In general, it really helps with water retention because it's like a sponge. So with volcanic soil, I don't know, it might need to be mixed with something else. We do always mix the biochar with something, either manure or compost or something. It's not generally just added just pure straight biochar. So I can't really answer that question 100% with the volcanic soil. I think I need to know like more specifics. But
in general, it has a positive impact on.
In general, for sure, it's like a sponge to help with water retention. Yeah.
Yes. Here's just a little side comment about from Michael. Thanks a lot for sharing this. Now,
Yes.
How can people, to close this off, this amazing session? We're putting a lot of bonus time, so thanks a lot, Fred, for being here, sharing with us, sharing with the Frogeex community, your knowledge and experience on that. how can people exchange with you? Of course, besides, Frogeex network, apparently, one of our like core members, working with bamboo or on bamboo for ages already. How else can maybe people become part of, this bamboo projects, or how can they kind of, join the network and maybe even file or apply for one project with you or something?
Sure, you can reach out to me on LinkedIn.
Mhm,
Really easy to find there.
mhm,
You can also check out our Planboo's website, which is planboo.eco,
mhm.
planboo.eco.
You're gonna
And
drop it
there's
then afterwards in the comment section, so you have it with
perfect,
you.
perfect. There's contact information on there. There's some articles on the blog section that explain some of the requirements and
Mhm,
some of the different features of our projects as well.
mhm.
And then,
So
yeah, if you have a potential project, definitely reach out to us. We can help you assess whether it's feasible, and yeah, and then if it is, we can work you through the pipeline of the feasibility study. Then
mhm,
we do a training where we come to the project and train you on the operation of the kiln and the operation of our technology to do the MRV, which is the measuring, reporting, and verification to earn the carbon credits, which is a whole other aspect of the business, which I didn't really get into here, but
yeah,
that's one of
let
the key things that Bamboo does. So,
yes. Thank you so much again, Fred, for taking the time. Amazing session today. Super informative, super inspirational. Also, thanks a lot for all the comments today. And let's keep it for the next one. Let's keep us posted and in touch regarding the updates on Biochar.
nice. Thank you, Jana. Always a pleasure.
Bye bye, everybody. See you on the next one.
Bye bye.